So in continuation with last class, we have to prove Perceptron Convergence today. So what is exactly convergence? So before jump into that, let us quickly revise what we were doing in Perceptron learning rule. So in Perceptron, we are implementing this change in weight rule, that is change in weight is equal to C into D minus O into X. So what happens when input belongs to class 1, you expect output to be +1, and so this is called as desired response, and actual output you obtain suppose -1. So it is opposite of this. Then in that case you add this change in weight. So this is change in weight, you will add to existing weight. Okay, now when your input X belongs to class 2, your desired response is -1, but suppose you obtain +1. Okay, so it is exactly reverse case. In that situation, you will subtract this change in weight from this existing weight. So these two things joined together, okay, will result into this D minus O term of this formula. So this will implement these two things. So sometimes you have to add, that means when your input is class 1, your response is negative, then you have to add. When input is belonging to class 2, your response is positive, you want negative output, then you will subtract. So these two things are simultaneously implemented in single rule like this. Now let us see what exactly is this Perceptron convergence theorem. So it is said that a classifier for two linearly separable classes is always trainable. So this is important thing. It is always trainable in a finite number of steps. Maybe steps are huge, like maybe 10,000 steps or maybe 1 lakh steps, whatever it may be, but it will converge. That means you will get a solution so that all samples are classified correctly. That is your training error is equal to 0. Okay, so you will learn all the samples. What is condition? Provided the two classes are linearly separable. If this is satisfied, then and then you will learn in finite number of steps. Now let us try to prove this. Now see this proof. Assume that W star is the solution vector. Solution, you can say weight vector. So what is that? I assume that W star is such a weight that all training samples are correctly classified and my training error is equal to 0. Since I don't know this solution, I assume that it exists for my linearly separable classes, that is two classes, and that solution weight vector is W star. This is unknown. Okay, we want to find out this. And we assume that this weight vector is normalized, that is its length is equal to 1. Norm of that W star is equal to 1. So we can normalize any given vector. As you know, suppose I give you 1 and 2, How I can do the normalization? You just multiply this with 1 over square root of 1 square plus 2 square. Whatever it is, you just compute, and that will be having the length equal to 1. So norm of this will be equal to 1. So this is suppose done. That means you have a W star uh, weight vector, that is as a solution, and you make the norm of that equal to 1. So this is done. Now training task is to find out such a W. So this is kept aside. This is kept suppose aside. I don't know this W star, but I just assume it that this is some W star that exists, and then I proceed. So what I do now, I take some W, that is current weight vector, multiplied by input, given input Y. I want this W transpose Y to be greater than 0 for each this Y. This Y is actually augmented X. So I am writing here for each X belonging to region 1. Similarly, W transpose Y should be less than 0 for each input that belongs to class 2. So this is class 1 and this is class 2. So why I want? Because what perceptron is doing, it is taking output as sine of W transpose Y. So when this quantity is greater than 0, your output is 1. When the sine W transpose Y is less than 0, output is minus 1. And I want for class 1 output is positive, and for class 2 output is negative. So that's why I want W transpose Y to be greater than 0 for class 1 samples, and W transpose Y should be less than 0 for class 2 samples. Now you can see, suppose this was my solution weight vector, some vector which solves the problem. The accuracy 100%. Okay, it's solving every sample correctly. And let us say this is some randomly assumed weight vector. Weight vector of what? A neuron, which is doing the job of classification. So what will be dimension of this? This will be dependent on what is input dimension. So you can see, if this is my neuron with input x1, x2 and up to xn, okay, so this will be w1, w2 to wn, and there will be one extra terminal for biasing purpose. So this will be wn plus 1. What will be output here? So output will be sine of W transpose Y. Okay, this will come as output, and this augmented input we are calling it as Y. And what will be weight vector dimension? It will be n plus 1. Okay, now what I am saying, I will initially randomly assume this weight, and suppose this is the direction of that weight, and this theta is the angle between W star and W. That is, actual solution is here, but you are assuming somewhere here. So the angle between the two vectors is theta. Now let us define a term called as, say, delta. Let delta be such that its value is in the range 0 to 1, so that W transpose Y, that is some input y multiplied by the solution weight factor is greater than this delta and greater than 0. So for class 1 samples, I hope you are noting down this derivation. You may not find all steps in the book, so better is you write along with me if possible, so that will be a good thing. So W star transpose y is a dot product is greater than some number delta is which is in the range 0 to 1 and greater than 0 for all samples that belong to region 1 or class 1. Similarly, I assume that W star transpose y is less than minus delta. Here it was plus delta. I am now saying it is less than minus delta, less than 0 for all samples that belong to class 2 or region 2. Now I take the dot product. I take the dot product of these two vectors. So this is W star transpose with W. What will be this? This will be W star norm into W norm into cos of theta. Okay, so this is nothing but the definition of dot product. Okay, like this. Now, if I bring this two terms to this side, okay, so it will be cos theta equal to W star transpose W divided by norm of W star into norm of W. And you know that the value of norm of W star is equal to 1 since we have already normalized. Okay, so since this is normalized, this is equal to 1, so I can write this as W star transpose W divided by just norm of W. This is not normalized, so this is as it is. So actually this will be 1 multiplied by that, so this one you can skip. Now what we are going to do is we are going to call this as psi of W defined as W. This is a measure. Okay, we will take help of this to prove the convergence. So right now just call this as some variable psi W. So this is W star transpose W divided by norm of W. So I am just calling this as psi W. That's all. So actually this is a cos of theta between W star and W. Okay, and what will be value of this? This value is always less than 1. Why? Because my range of cos function is -1 to +1, so it will be always less than 1. I hope this is clear. Now the real derivation starts here by taking help of these two terms. So what happens to these two terms during our training? Now suppose I have presented first pattern, and since there is an error, that means I was expecting +1 but my answer is suppose -1 since my input y belongs to class 1. Okay, so what is remedy? Remedy is to add change in weight to the existing weight. Now here I assume again C is equal to 1 or let us say 0.5, so that this D minus O D minus O is in general plus or minus 2. If I assume C is equal to 0.5, so this will be equal to plus or minus 1. So my further my this derivation becomes easy. So C will not come into picture now. So what is W1? That is new weight is equal to old weight, that is 0th iteration or 0th step in this case, plus Y, that is input. Now we will multiply this by W star transpose. So multiply this equation by W star transpose. So I can multiply this by W star transpose here, then this will be W star transpose here, and then take this inside. So if you expand this, this will be the step. Now, after k steps, for k plus 1th step, assuming that such things or errors are occurring continuously, and I am in this k plus 1th step. So what will be this k plus 1th step? I can write here separately. Wk plus 1 is equal to W star, sorry, this will be Wk plus Y, and then I multiply both sides by W transpose, W star transpose and W star transpose. So if I expand, then I will get this. Okay, I hope you are noting down this. So what I have done, I am just taking the first step, was first training step, and just multiplying by the solution. So that is our step number 1. Then what I do is I intentionally skip this quantity. This is W star transpose Y. If I skip that, what will happen? I know the relation between delta and W star. So what was that? I was assuming that W star transpose Y is greater than delta greater than 0. Now what I am doing here intentionally is I am skipping this number W star transpose Y and replacing it by a smaller number. So delta is a smaller number compared to W star transpose Y. So if I replace this by a small number, so this equality will go, and this W star transpose multiplied by W k plus 1, this will be greater than this side, because suppose this was say 1 or maybe some number like 2, say W star transpose Y is 2, and I am replacing it by say small number 0.1. So delta is a small number that you will define. So the user has defined suppose 0.1, then this equality will go, and this will be a lighter quantity, so this will be greater quantity. Now reason is W star transpose Y is greater than delta. Now if I keep on doing further steps, then I can say from equation A and B, what it is saying, W star transpose Wk plus 1, I'm just writing the previous step here, W star transpose Wk plus delta. Now if I do next step, that is W star transpose multiplied by Wk plus 2, then it will be greater than W star transpose wk plus 1, just replacing here k plus 2 and here it will be k plus 1 plus again delta. Now what I can do is I can replace this term using equation A. Okay, I can replace this using equation A. So this W star transpose multiplied by K plus 1, I am replacing with the help of previous equation. So you can see here I am writing W star transpose WK plus delta. Okay, so this term I am indicating like this. So this term which is here is replaced by this group. Okay, plus previous delta. So this delta is coming here. So this product we are using equation A and rewriting it. So if I solve this, so this delta and this delta becomes 2 delta. So this will be W star transpose WK plus 2. So this quantity is greater than W star transpose into WK plus now 2 delta. Now still if I keep on doing this K plus K0 times, so if I do this step from 2 to K0, okay, so what will happen? I can again write in the same way. Okay, so this with the help of equation suppose C, I can write straight with that. Keep this first term as it is. I can just add K0 delta since I have done K0 steps after the step number say B. So I have done so many steps, that is training steps. These are all training steps. K0 such training steps. So finally, write down this equation number 1, which says W star transpose WK plus K0. So this group is written over here is greater than K0 into delta. Now even I am skipping this term. Okay, so since this K0 is a big number, I can drop this small quantity, and dropping this will result again imbalance, and this will be greater than K0 delta. So you give this as number 1. Now we will go to this other term in that cos theta. Remember what I am doing is, we know that cos theta, we know that this is W transpose Y into W divided by norm of W. So that we have defined already. So I'm dealing with this term and landed to this equation number 1, and then I'm now dealing with the second term. I will run to equation number 2. So for the first step, so this is for the first step, norm of W1 vector square, that is when I say W1 is equal to W0 plus Y, so this is a weight vector after first training step. Okay, now if I take norm of this, so it will be length of this vector, and if I square it, okay, so it will be equal to W0 plus Y transpose W0 plus Y. Okay. Since norm of a vector, say norm of a vector is this symbol norm of vectors, that is W. If I square it, this is equal to W transpose W. If you take a vector and make a dot product with itself, it will be known as norm square. If you take square root, it will give you correct length of that vector. Now if I take this first vector after training, W1 norm square, then this will be actually equal to W1 transpose W1. So I replace this W1 with the help of our training step, that is W0 plus Y transpose into W0 plus Y. Okay, try to simplify this. So if you simplify this after say k steps, so you repeat this after k steps, what happens? You can write for k plus 1th step, norm of weight after k plus 1 step, square of that is equal to wk plus y transpose wk plus y. Okay, so I am writing from the previous step after k steps. Now if you make a product of this, you will get this expansion, and you can note down these two things you can add up. Now here, be cautious. I am replacing this y transpose y by 1. What it means? It means that all training samples, anybody, all training samples are normalized. Then and then I can replace this W transpose Y equal to 1. Why? Because W transpose Y is nothing but norm of Y square. And if I have normalized this vector, then its length is 1. So 1 square is 1. Okay, so note this thing, that all training samples are normalized. Two things are normalized in this derivation. First one is solution weight vector, that is a hypothetical solution weight vector W star is normalized, and Y, that is training samples, are normalized. So all the training samples are normalized. Okay, so now what I'm doing is I'm skipping, this is an important step in this derivation. Many students do not understand how this is happening. Since I am dropping now this term and still saying that this side is bigger. Can you think why? I am dropping term from this side, say right hand side, and left hand side is becoming lesser. Okay, so left hand side is less than these two terms, even though I am dropping this term from right hand side. So since my input is belonging to class 1, output is -1. Okay, that's why I'm doing training. Why training will come into picture? Training is coming into picture because wk transpose y is less than 0. That's why this training is coming into picture. My input is class 1 and output is minus 1. Okay, so this term is a negative term. So if I drop this negative term from right hand side, the remaining quantity will be bigger than this left hand side. For example, suppose I write here 98 is equal to 100 minus 2. So this minus 2 is this quantity. Okay, and 100 is suppose this first quantity. If I drop this, what will happen? This 98 is less than 100. So that is why I can write like this. I hope you understand this. Okay, so this is because wk transpose y is negative. Now if I do further steps, same as in the previous case, so if I keep on doing steps, suppose I do wk plus 2 norm square, then it will be equal to wk plus 1, it should be norm square plus 1. Now if I replace this by previous equation, I can write like this plus 1. So this plus 1 and plus 1 will get plus 2. Now if I do again k0 times this step, so I can write this as k0, which is a big number, so I can even skip this step. Now we have two equations, equation 1 and equation 2, and I substitute these two in our cos theta equation. So if I write cos theta, that is psi of omega, psi of wk plus 1 equal to w star transpose. So this is a fixed quantity. Then since I have followed k0 plus 1 steps, okay, so I have done so many steps divided by norm of that. So this is coming from our earlier definition. Here what I am saying, I have done k0 plus 1 steps. Okay, so this w star will remain as it is. So this is equal to 1. So this will go and only this will be there. Now when you substitute values of these two things into this equation, now see, this k0 delta is written here, this k0 is written here, square root actually, because this is norm and we have done calculation on norm square. So wk0 plus 1 norm square is less than k0. So if I take square root of this, then this will go, so it will be actually norm of wk0 plus 1 less than square root of k0. So when you substitute a and b and simplify these two things, so this will be greater than square root of k0 into delta. Okay, so this is a greater divided by smaller, so this will result into a greater. Now upper bound, we know that this angle cannot be more than, so our cos of theta cannot be more than plus 1. So this can't be more than plus 1. So that is our knowledge from cos of that angle. Now, so what happens is this square root k0 into delta can't be greater than 1. So this term cannot be greater than 1. Okay, so this term is always or at the most equal to 1. This cannot be greater than 1. So that is our cos of theta. So that means, so k square root of k0 into delta is always less than 1 or at the most equal to 1. So max learning steps. So I just take this k0 this side and take this delta this side. Okay, so that means square root of k0 is always less than 1 by delta, and if I square these two things, so this will be 1 by delta square. So that is what is written here. So at the most cos theta is equal to 1, so I can put here 1. So k0 is at most 1 by delta square. Since delta is a small number in the range 0 to 1, we know that this will never be infinity. Okay, so that's why since k0 is a finite number, it means that number of steps are also finite. Okay, so this proves the concept of convergence. So what it means, when you start training a neuron or a perceptron using delta learning rule, you will end up your training within some finite number of steps. Your training will not be in an infinite loop. That is a guarantee from this perceptron learning rule. So only thing is, you must have data which is linearly separate. Hello? हाँ सर. हाँ हाँ. नाही काही गरज नाही, संपलं दुकान संपलं. काय गरज नाही. 14ला एका दिवसात 14 तारखेला. नाही गरज नाही. हां, तेच मी विचार केला परत जाऊ द्या मला शेपूट द्यायला वाढला. हो चालेल, 14 ठेवून दिलं मी. 14 ठेवून दिलं. हो 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 येस येस ओके. Okay, then in next class we will see multi-category single layer neural network, how to train this using perceptron learning rule. Okay, let us stop here.